The screencast topic is going to be about fronts. If you haven't already learned about air masses, you should go back and watch the screencast and look at the presentation about air masses because you need to know about air masses before you learn about fronts. The second thing for my disclaimers is that this is kind of a difficult topic, so don't be embarrassed to stop, rewind, or very importantly, don't be embarrassed to ask a teacher for help about this. But let's go ahead and move through. Today we're going to learn about the 4 different kinds of fronts and talk about how they affect weather. And you're going to collect information about how fronts behave in an organizer that looks like this. Alright, so I'm going to do my best to help you fill this in, but you're also going to have to fill in a lot on your own. Make sure you have your reference table handy, and then we'll begin. Okay, so the first thing you should do is get this definition of fronts into your vocabulary section in your notebook. Fronts are the boundaries between 2 different air masses. So you often see them on weather maps. They're these big colorful lines. They're usually blue or red or a combination of blue or red or purple. Those are the only colors you'll see. Of course, in the regions they don't use color, so you need to be able to identify fronts based on the shapes. So they give you a nice way of doing that here at the bottom of page 13. So down here, look for fronts. You can see cold fronts are triangles, so they're blue triangles on a weather map. A warm front is shown by these little semicircles. Those are colored in red. A stationary front shows the triangles pointing one direction and the red bumps pointing the other direction. They're kind of locked together like a zipper. Okay, and then the last front and the most complicated front is the occluded front, and that has the triangles and the warm bumps alternating and pointing in the same direction. We'll talk more about what the directions and everything means, but just so you know where in the reference table you have this information. Page 13 along with all the other weather stuff. That whole page is just a whole page about weather. Alright, so back to the lesson. The front represents literally the front of an air mass. So if you're talking about a front, here we see a big cold front. That means that everything behind it is cold air, and this is the front edge of that cold air. And then here's a little bit of a warm front, so that means everything behind it is warm, and the warm air is moving up. So that's the next important thing to understand about fronts, is that the direction that the arrows on the cold front or the bumps on the warm front, the direction that they are pointing is the direction that the front is moving. So here we can see that this cold front is moving to the south and to the west, and this warm front is moving to the north and to the east. Over here there's another cold front that's kind of moving basically just straight east. Alright, so now we're going to start to fill out this handout. So if you don't have this handout handy, get it out and get ready to fill it in. I'm going to do my best. I'm going to show you how to do the stationary front and the cold front, and then you'll do the warm and occluded front by yourself. Warning, the occluded front is really complicated. You need to make sure that at the end of this screencast you have a teacher check and explain to make sure that you understand everything. Okay? Alright, get this out and let's get going. The first front is the stationary front. So stationary means it doesn't move. Alright, so a stationary front, you can see you have red bumps representing warm pointing one way, and blue triangles pointing the other direction, and so they're kind of locked together. So a stationary front occurs when you have a mass of cold air and a mass of warm air, and they're really kind of at equilibrium, and they don't overtake each other. They just kind of hang out together until one becomes more powerful than the other. So let's get that description um, into our organizer. So a stationary front is when cold air, let's make this a little bigger. Fonts, let's put that at 11. Cold air and warm air masses meet but do not mix or force each other out. Alright, so that's kind of the description of what's going on. They're not moving a lot. The picture that I would draw would be something like this. Okay, so you want to show a cold air mass on the left and a warm air mass on the right, and they're really not doing anything to one another. So let's see if I can kind of show that in here. Bring this in, shrink it way down. So it is important that if you are trying to copy the the images that I'm making, that you make sure that you keep the cold front and the cold air masses and the warm air masses on the same sides that my pictures keep them, because all of these columns below are talking about the temperatures and the dew points and the weather stations in that air mass, right? So for example, in the cold air mass, we're going to have cooler temperatures. And in the warm air mass, we're going to have, what do you think? Warmer temperatures. Alright. We use the phrases cooler and warmer because it's not always cold. A cool air mass in the summer may only get down to 60, which right now, when it's really cold outside, doesn't feel cold, but it is a cooler temperature. The same way that a warm air mass in the wintertime is not going to be like 80 degrees. It's probably going to be more like maybe 40 or 50. So we're going to use cooler and warmer. The dew point. So in cold air, a dew point is going to be lower because cold air does not hold as much water as warm air. And so in a warm air mass, the dew point is higher. Oh, if Jordan can spell higher, there we go. Your weather station example. So this is going to be hard for me to show really clearly. Weather station example, you're going to write your temperature up here, and you're going to write a dew point down there. So let's see if I can do it. So let's think of a low temperature. Let me say it's like a spring day, so let's say this is a 35 degree. Alright, and then on the warmer side, right, on the warm side of my picture, it needs to be a little bit warmer than that. So let's say that it's 50. Okay, what you should not do is don't do something like, oh, it's really cold over here, it's 20 degrees, and it's hot over here, it's 80 degrees, right? That doesn't happen. You never have a situation where it's 80 and then it goes all the way down to 20. So let's go back if I can remember. It's like 50. Oh, no, let's do like a 40, 400. No. All right, 40 and like 65 degrees. 40 and 60, whatever. That's pretty good. Now you're also going to need to make a dew point temperature. Alright, so dew point always goes in the bottom left. So if we have low dew point, then we need to keep this temperature low. And if we have a higher dew point, we're going to get that temperature a lot closer to where the temperature already is. So the dew point here, let's make it 50. Alright? So that's how your stationary front column should look. I'm going to do cold front, and then I'll explain what warm front and included front look like, and you'll need to draw them into the columns. Oh wait, I forgot to show you the animation. Ah, this is so cool. So here's actually what happens in a stationary front, right? So watch, the cool air moves in, the warm air also moves in, and because they're kind of the same sort of force, where they meet, you're going to start to have some small clouds forming. Eventually there could be some precipitation along that front line where the two of them meet, but as you can see, neither of them move each other out. That's why they're called stationary. Alright, let's just start by looking at what happens in the cold front. So in a cold front, you have a big, heavy mass of cold air. Cold air is much more dense. Remember, we learned that with the balloon. So the cold air moves in. As it moves into warm air is forced up above the cold air. The warm air is less dense. So as that warm air gets forced up, you see that you're going to have rain right along the front edge. So why does rain happen at the front edge? Well, as you force warm air up, here comes the cold air in. Oh, now the warm air has to get above because the warm air is less dense. As you force warm air up, you cool it off. And when you cool off air, it can't hold as much of the moisture, so it has to drop that moisture in the form of precipitation. So in the front of a cold front, you will have often some really strong, powerful storms. Okay, so let's go back and just show a picture of what this looks like on the side, right? So the warm air gets forced up, and there you have your storms occurring. Notice how cold the air is behind the front and how warm the air is in front of the front. Also notice that the arrows on the front show you the direction that the cold front is moving. So this cold front is moving from left to right because that's where the arrows are shown. So let's write a description for the cold front. A cold front is when cold air cold air mass collides with warm air, it forces the less dense warm air up. This causes precipitation. Okay? That's a description of what's going on in a cold front. Alright? Your picture can look something like that. Again, you want to make sure that you're paying very close attention to... Whoa, what am I doing? You want to make sure that you're paying very close attention to how you're drawing the picture in your box. Alright, so if your picture has the cold air on the left, like mine does, then you need to make sure all the information going down that left column is cold. Okay? So you're going to have cooler temperature in the air mass, warmer temperature in front of that air mass, again a lower dew point inside cool air mass and a higher dew point outside. Alright, and the temperatures can be similar down here. I'm going to let you now do the warm front and occluded. You're going to have to fill out the warm front and occluded front part of this handout without me, but I do want to describe what those fronts look like and how they act, okay? So once you've finished filling in the information in these two columns, move ahead and we'll talk about warm fronts. Okay, so let's look at warm fronts. By the way, you have access to these animations, so you should definitely look at them by yourself when you pause the video. So in a warm front, you have warm air moving in and it hits cold air. Alright, it slowly forces that cold air out, but again, warm air is much less dense than cold air, so it doesn't go underneath the cool air. Instead, the warm air kind of rides up the back of the cold air, and as it rises, once again, it increases in elevation, meaning that its temperature cools down, and so as its temperature cools, it cannot handle as much water, and therefore it drops that water. So here in front of the warm front, you have kind of long, gentle rains. Alright, let's watch that video one more time. Warm air moves in, so the bumps would be kind of on the right side here. Sorry if you're hearing my little baby in the background. And so the warm air is pushing its way up. The clouds start to form as the air rises and cools and condenses. Then eventually it gets so cold it can't hold that water anymore. It drops the water and precipitation happens. Alright, so now you should pause the screencast and record all the information about what happens in these warm fronts in the correct columns over here. Alright, now I'm going to explain occluded fronts. These are very, very complicated, so bear with me. So an occluded front happens when you have like a warm front that gets caught up to by a cold front. Alright, so you have this rapidly moving cold front kind of swinging into a warm front, and what ends up happening is at the top where they start to meet is they mix together. And here's what that looks like on the animation. Alright, so let me pause it. So you have this mass of warm air, so this is a warm front right here, and here's a cold front coming in behind it. So you have cool air over here and colder air behind the warm front, and the warm front is trapped. So the cold air rushes in, and now the warm air is trapped because it can't go through cool air. Cool air is more dense, and it has to rise up above. And so that trapped warm air rises up. Alright, and you're going to have some really intense storms as that air is forced up because you have the very cold air behind it and the cool air in front, and so really heavy thunderstorm looking clouds. These clouds are called like thunderheads, I believe cumulonimbus clouds, and they cause a lot of crazy weather. Alright, so I know occluded is kind of tricky, and I know I've kind of rushed here at the end, but make sure now that you go back, fill in your entire handout, wherever I put that handout at. It's in here somewhere. You know what it looks like. Fill in the rest of the handout. This is going to be really useful notes for your milestone, and if you have any questions, make sure to ask a teacher. Alright, hope this was helpful and not too long. And it's looking pretty long, but hope you enjoyed it. Alright, bye.